summation based function here. So let me write out a few of the terms here to get an idea of how we're going to proceed. This is the floor function, and for I equals 0, the very first summand would just be the floor of x. And again, that's for I equals 0, floor of x. Okay, because if I is 0, this term certainly is not present. Okay, and then for I equals 1, we're going to have the floor of x plus 1 over 81. Okay, we can just do just a few more here to get the pattern going. And then for I equals 2, we'll have the floor of x plus 2 over 81. Okay, now we can just write down the last term just to make it look relatively professional here. Okay, so we have plus ellipsis plus, in the very last term in this series, this finite series, is going to be x, the floor of x plus 80 over 81. Okay, and we're actually going to use this in conjunction with something called Hermite's identity. Now let's talk about the floor. Just what does the floor function actually do? Okay, it's sometimes called the greatest integer function. An example would be, like, say if you had the floor of let's say 6.8 here, floor of 6.8. Okay, you always just chop off the decimal portion, and so that's going to be equal to 6, which is certainly an integer. And that's because 6 and 7 are the lower and upper bounds for 6.8. So 6 less than or equal to 6.8, strictly less than 7. Okay. And it works for negative integers too. For example, believe it or not, and you can verify this on your own, but if you had, say, like the floor of minus 1.3, this used to confuse me, but this is actually equal to negative 2. Okay, that's just the direction of the negative integers, basically. Okay, so it rounds it to the greatest negative integer that's less than minus 1.3, which is negative 2. So that kind of confused me when I first saw that. Okay, but let's move along here, folks. Now, this result that we have is quite useful. It's called Hermite's result, or I guess it's an identity. Now, I've looked at the proof. I couldn't reproduce it for you if I had to, you know. But notice it's going to give us, based on this formulation, this is what I've written down right here is this series. So what we can do is replace this entire series just with 81, the floor of 81x. So let's write that down just here, adjacent here. So we can, according to Hermite's identity, we can rewrite this simply as the floor, and it's powerful. I mean, we don't have to do hardly anything. It's just doing all the work for us. 81, the floor of 81 x. Solving this is equivalent to making some serious progress on the problem we're trying to evaluate here. So there we go. Okay. Now don't forget, we're trying to actually show that when you substitute x equals 1001 divided by 162 into this summation function, you get 500. Okay. So let's see how that could possibly be true. All right, now what we can do is to get a range of solutions. If you take a look right here, if you take a look at this result right here, this is the very same thing, okay, is saying that 500 is less than or equal to 81x. Okay, and we're just using the definition of the floor function right here. Okay. Ladies and gentlemen, I just want to make sure you know all I did was just use, in lieu of x here, I just used 81x. Remember, x can be any expression at all. So I used 81x. Now notice this sandwiches sort of nicely. What we get right here, just writing, if you divide through by 81, you won't change the sense of the inequality. You're going to get 500 over 81. Okay. Now we have x trapped between these two values, less than or equal to x, less than or equal to 501 over 81. Now you probably see exactly where this is going. Any x in this narrow interval, this is a number a little bit larger than 6. This is a number a little bit larger than 6, right? 6 times 81 is, I think, still less than 500. Okay, so notice that the midpoint, in other words, 16, if you sum up these two numbers, I'll just write it down. 1500 over 81. Sorry, that's 1500, 500 over 81. Let me erase that. Okay, now, so that's 500 over 81 plus, I'm doing the midpoint, folks, 501 over 81. Now again, y'all, midpoint, divide by 2. Divide by 2 right here. Let me get a little more space here. Okay, divided by 2. Now notice that's our number, right? That's going to be equal to, you add those two up, you get 1001, right? And and then you multiply 2 times 81. It's just properties of fractions, right? See, this number is the midpoint, so it's contained in this interval, and that means it has to have a floor of 500, right? So we can conclude, since this number is definitely contained in this interval, it's an x that's trapped between these two values. We can write down that the floor of this is equal to 500. And we've proved what we set out to prove, folks. Now, there's a way to do this, I think, just doing arithmetic progressions. Remember, this would be your f of x, the way we defined it. You know, your f of x, f at 1001 over, okay? Or let's just run back up. I'm sure you guys got it, but we defined f of x to be that floor function, right? We wanted to show that f at 1001 over 162 was equal to 500. And that's what we've done with this demonstration. Now, Hermite's criterion, bore the burden here, but let's get that circled. Okay. And y'all, that does it. I hope you like that. I think it's kind of neat. I'm more interested in this Hermite's result. It's a tough proof. I've looked at the proof a few times, didn't have much luck with it. I sort of have an idea, but I just stated it as a result, and a powerful result it was. It really helped us with this problem. Thanks for viewing.